Okay, hello. Happy New Year, everyone. Welcome back to our first lesson of 2022. Okay, Justin, hello. Okay, anyway, what are we doing today? How's your holiday, by the way? All right, what are we doing today? We are doing revision for your finals. Okay, yes, Jivan, hello. I'm sorry to say, but we have to do revision for today. But the good news is we were supposed to do this in 2 weeks. Okay, the space chapters, you have it in your form 2, you have it in your form 3. The good thing is many of you are having your finals in these 2 weeks. So I will try to rush this thing in one lesson. Okay, it's gonna be a very compact lesson. So please stay with me. I will try to rush this thing as fast as I can. I mean, come on, some of these are just mindless, I would say useless chapters. Okay, it's more of a general knowledge chapter. Okay, yes, hello Pritika, how are you? What chapter is this? This is all your space chapters. I already posted this in Google Classroom, by the way. If you need the soft copy, you can download it from there. I mean, if you haven't received your physical copy lah. Yes, hello Pritika, happy new year. Okay, anyway, let's begin. I will go through all the space chapters, which is your Form 2, Chapter 11, 12, and 13, and your Form 3, Chapter 10 and 11, if I remember correctly. You haven't received, then it's okay. Go to your Google Classroom. It's already posted there. Okay, so anyway, I will go through this, and next week we shall do something else. Because let's face it, this is a very boring chapter. These are very, very boring chapters. Not gonna lie to you. Okay, so let's look at Form 2, Chapter 11, Stars and Galaxy. Okay, I'll do it in dual language as much as I can lah. So your galaxy has 3 types. You have the spinny one, you have spinny, roundy, and don't know what. I just call it cincai. So the spinny one is called spiral, burpilin in DM. And you have the roundy one, elliptical or ellipse. And you have the cincai one, we call it irregular, tidak seragam. Okay, so galaxies are classified as their shapes. So these are so far the 3 shapes that we know. Our Milky Way, Bima Sakti, is an elliptical one. Sorry, it's a spiral one. Okay, we are the spinny one. Okay, that's all you need to know. I mean, it's not really important. Don't go and memorize all these. What is this? Andromeda, Ursa Major? No, 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 no. That's not your concern. You don't need to know. Okay, so let's look at the birth of a star, shall we? This is one of the main point of this chapter. So how is a star born? Okay, let's look at this diagram. In fact, this is the only diagram that you need to know. Okay, so all stars, they start from a bunch of dust and gas. We call it nebula. Okay, in case you don't know who Nebula is, she's the second daughter of Thanos. Nebula, okay, so nebula is a bunch of dust and cloud. They just come together because of gravity, strong gravity, then boom, oh, they light up. They start doing nuclear fusion. Yay, you have a sun, you have a star. Okay, those of you who watch, if you watch Marvels, you get what I mean lah. So we have 3 shapes, 3 size star. We have our medium size, okay, size bintang sederhana, and then you have bintang besar, large star, and then you have bintang super besar, okay, I guess. So of course, this is the birth of star. Okay, kelahiran bintang. And when, okay, a star will use hydrogen as the fuel. Is it mentioned here? No, I'll just write it here. Okay, just remember this. A star will use hydrogen as the fuel, and then they will do nuclear fusion. Okay, you will learn this in form. I think you learned this before already, right? Nuclear fusion. That means they fuse together, and then this hydrogen will become helium. Okay, so you can say that hydrogen is the fuel, the bahan api, and helium is the exhaust. That's the wasted gas that they throw away. So this is how you get your energy from a star. Okay, yes, Amizan, hello, happy new year. Okay, so this is how you get energy from a star lah. So when the hydrogen starts depleting, when a star is running out of hydrogen, it will go towards death. Okay, death of star, kematian bintang. So in this case, our sun is this one. Our sun is a medium-sized star. So since this is a medium-sized star, when they die, it's less dramatic. Okay, are you teaching physical? I'm not teaching physical in Old Town, I'm sorry. Okay, physical will be passed to my junior. Okay, so you won't see me physically in Old Town. Okay, anyway, so it will turn into a red giant. Okay, funny enough, in BM, this is called Raksasa Merah. Okay, the translation is another level lah. How can they translate giant into Raksasa? This is beyond me. The translator must be drunk or something. Oh, I shall call it Raksasa Merah. Okay, I've been scratching my head since I'm Form 3 until now. Why is it called Raksasa? I have no idea. Okay, you're sad. Don't be sad. You can still see me online. So dumb, yeah, I know. Tell me about it. Okay, so red giant is when they are running out of hydrogen, and when they fully run out of hydrogen, no more hydrogen, they will stop burning and they will turn into a white dwarf. This is called Kerdil Putih. When they reach this stage, it's like a very sad star. They will just float around space doing nothing. They have no purpose anymore. Sad. Okay, I'll teach in KK. Yeah, I will still be in KK. Don't worry. Okay, so that's your Kerdil Putih. Next, let's look at your large and super large star. These, they go through almost the same process as they die. So they will turn into a red giant. Okay, since they are very big, they are more dramatic when they die. So they will turn into a super giant. Okay, the translation is even funny in this case. It's called Super Raksasa. Okay, the translator got so lazy, he didn't even bother to translate super. Okay, it's like Super Raksasa. Okay, you know what? I'm just too lazy. I'll just call it super. Okay, Super Raksasa, and then they will do supernova. That means there's a bomb, there's a bang. They go out with a bang. And for a large star, they will turn into a neutron star, and a super large star will turn into a black hole. Super idol. Yeah. Okay, I don't know why they translate it this way. Okay, so you know what's a neutron star? Okay, for those who watch Marvel, Thor did say that his hammer, the Mjolnir, is made from neutron star. Okay, that's why. Oh, Nova 2. Oh, that's a cute name. Okay, so if you watch Infinity War, that's where Thor he didn't have his hammer anymore. So what he did was he went to Nidavellir and he wanted to make another new axe. Remember the Stormbreaker? So the guy told him to open the star because they need to extract energy from a dying star to cast into a new axe. Okay, that's comic lah. It doesn't make any sense, but hey, it's cool. Okay, so they say that the Mjolnir hammer is made from neutron star, so it makes it very heavy. Only those who are worthy can possess the power of Thor. Okay, any Marvel fan here? Okay, so the Vanilla and Silver. Why Vanilla? Vanilla is a cool name. Okay, that's cute. Okay, anyway, so this is how your star dies. This is a very important process. Not say very important lah, but this part will most likely come out in objective, I would say. Okay, so you don't need to go crazy here. You just need to roughly know how they die. Okay, next, star, how are they classified? They are classified based on the size, distance, brightness, temperature, and color. Okay, size, jarak, kecerahan, suhu, dan warna. How about our sun? Okay, our sun is everything middle. Our sun is not too big. Okay, they are medium size. Distance, they are the closest to us, lor. Brightness, they are middle, you see. Temperature, color, also middle. Our sun is here. Okay, our sun is not too cold or not too hot. Okay, blue is super hot. It's like your mom's kitchen fire. Yellow fire is the lousy fire. If your mom, I'm sure your mom cooks with a blue flame. That's a really hot flame. That's like what, 4 or 5 times hotter. So that's a very hot star. Yeah, our sun is okay in the middle. Okay, so not too big and not too small, not too hot or not too cold. That's all you need to know. Okay, so anyway, let's look at our solar system. Okay, so there are 2 units you need to know. First is the AU, or we call it the astronomical unit. Okay, or the light year, or we just call it LY. Okay, I'm sure you have learned how to calculate this before, but you you will tend to ask, sir, why are we learning this? Why do we need to know all these numbers? Here's the thing. AU and LY is to let you express a very big number easily. Okay, a very, very big number easily. For example, 1 AU is the distance between the Earth and the Sun. Okay, so that means from the Sun to Earth, this is Earth, you can either write 1.5 times 10 power of 8 km, or you're just very lazy. Sir, I don't want to write this long. Then you just write 1 AU lah. People will understand. Okay, it's like this. If you have a friend who is very stupid mathematically, his maths is like another new level of stupid. If you tell him, oh, I just bought a new phone. My phone is 15 cm long. He'll be scratching his head. How long is 15? Oh, 15 cm is 115 mm. Then he will say, how much is that? I don't know. You see some people, they're very stupid one. So instead of saying 15 cm, you say, okay, my phone is 1 banana long. Okay, now I understand. You might say, sir, banana got a lot of size one. Okay, you just think of the most normal banana. It's like around this long. Okay, my phone is 1 banana long. Oh, okay, now I understand. You see, some people, you need to give them this kind of figure. So same thing here. Instead of saying 1.5 times 10 power of 8 km, oh, I don't understand this number. This is so big. Okay, this is 1 AU, 1 banana. Okay, from the sun to our sun to Earth is 1 banana long. Well, that's a very big banana, but you get my point. Okay, we just use banana as the measurement. So that's your 1 AU lah. So 1 light year is the same thing, 9.5 times 10 power of 12. Instead of writing this number, you can write this number instead. So should you memorize these two? No, it will be given to you in exam. So don't you worry. Okay, you don't need to memorize this. Okay, there's no special marks for you. They will give it to you. All right, so all these planets, do you need to know all these numbers? No, you don't. All you need to know is our planet. We have 8 planets. The first 4 is rocky planet. Planet Batuan. You can stand on it. It's made of stone. The next 4, Jupiter, Saturn, Uranus, okay, Uranus and Neptune. These 4, they are gas planets. They are gas giant. You cannot stand on them. They are like clouds. Can you stand on a cloud? No, you can't. So these are basically cloudy, gassy planet. That's all. Okay, that's all you need to know. Okay, how many days they rotate the sun and blah, blah, blah. No, okay, that's not none of your concern. Okay, this is more like a read for fun chapter. Okay, as I said just now. So relationship between temperature of a planet and the sun, I'm sure you know this lah. The further away from the sun, the colder it gets. Well, common sense. The closer you stand to a fire, the hotter you feel. The further you stand away from it, the colder you feel. Okay, so that as you can see, all these giant planets, they are pretty freaking cold. Okay, sub-zero temperature. And if you look at Mercury, Venus, Earth, and Mars, you might say, sir, why is it so weird? Why is Venus so hot? Why is it hotter than Mercury? Okay, because you see, why is Mercury such a big difference? Because Mercury, it doesn't have an atmosphere. Okay, do you know atmosphere is very important to keep your planet warm? Mercury doesn't have one. So it can either get super hot in the morning or daytime. At night, when it is not facing the sun, it can be really cold. Okay, stupid cold. Okay, whereas Earth, Venus, Earth, and Mars, we have atmosphere. Okay, so what makes Venus so hot? Because Venus has a lot of carbon dioxide. As you know, carbon dioxide will cause global warming, right? We are currently dealing with this problem. Venus is a planet full of carbon dioxide. That's why they are so damn bloody hot. Okay, whereas Earth and Mars, we are the middle ones. Okay, so you see, Earth can be negative 90-ish to 50 something, that's a 100 something degree difference. Mars is even okay close, it's almost the same negative 143 to 35. That's why you see, why are we so obsessed with going to Mars? Okay, you ask Elon Musk, you get what I mean lah. He is obsessed with Mars. Every time you hear SpaceX, oh, we will put man on Mars in 5 years. Why is he so obsessed with Mars? Because Mars is the only planet in our solar system that is habitable. Not really habitable, but it is close. Okay, you see, it is really close to Earth. Okay, they are next to Earth. Gravity is almost the same. Temperature, okay, they are colder, but almost the same too. But the problem is there's no water there. Okay, so it is still pretty much inhabitable, but hey, he's making it work. He has all the money. Okay, so who knows? 5 years later, we'll be staying there. You'll see people staying there. Okay, I don't see it, but who knows? All right, so this is your what I explained just now. Mercury has no atmosphere. These three, they have atmosphere. The other 4 giant planets, okay, they have basically they're gases. So that's why they're so cold. All right, so density, gravitational pull, distance, this one you read yourself. Don't focus. Don't focus. This is not your concern. Okay, the only thing you need to know here is every planet will rotate from west to east. That's why you see sun rising from the east, except 2 planets, which are Venus and Uranus. These 2, they just like to be different. They just spin in a, opposite direction. Don't ask me why, that's the way they are. Okay, so anyway, what happens when you have solar system, okay, when the Earth stops rotating or whatever, okay, read this yourself, or this, read this yourself. Okay, I'm kind of rushing here because we are supposed to do this in 2 weeks. Now I'm shoving everything in 1 week, so it feels kind of rushy. Okay, anyway, so this ecological footprint is kind of out of place thing. Read this yourself. I'm not even gonna bother. Okay, next, moving on. What is meteoroid, asteroid, and comet? Okay, this is really simple. Meteoroid are small stones. Okay, small stones. Asteroid is a big ass stone, really big. How big? They can be 1,000 kilometer. Hey, 1,000 kilometer is Peninsula Malaysia, Imagine there's a Malaysia-sized stone crashing down. Well, you better be running and praying because we'll all be dead. Okay, meteorite, it's not so much. Okay, meteorite is like 1 meter. That's the biggest they can get. That's like, it's just like a small stone. Okay, pretty much it. Comet, basically, this is an ice, a ball of ice. Okay, an ice with a tail. That's all. Okay, they are not stone at all. So each has their own characteristics. So our focus will be meteoroid. So there are a few terms you need to know. When meteoroid, they crash into Earth, some of them they do. Okay, time to time they'll crash into Earth. And when they crash into Earth, they happen to come into our gravity and they start coming down towards Earth. We call it meteor. Okay, meteoroid, when they come in, we call it meteor. Okay, and when they come in, okay, you might say, sir, won't this thing hit us? No, the chances are really, really small. Really small. Even smaller than you hitting a lottery jackpot. So that's really pretty freaking small. So don't you worry. Okay, so meteor, before they reach the Earth, they are already finished burning. There's nothing left. Since they are so small, our atmosphere is so tall, by the time they reach here, the friction will already light them up. There's nothing left. But there are some rare cases, some meteor is big enough to reach our Earth's surface. When they do, we call it meteorite. Okay, if this thing hits you, congratulations, this is as good as you hitting the jackpot because you can sell this. Okay, scientists will say, hey, can you sell this to us? We want research or something. Then say, okay, I can sell it to you, $5 million. Wow, you see, that's like hitting the jackpot, the lottery jackpot already. So you pray hard, this thing will hit you, lor. But they are really rare, lah. Okay, I've not seen one before. Okay, so if there is a bunch of meteor that crash into Earth, we call it meteor shower. Okay, I have not seen this before either. Okay, there was this solar eclipse 2 years back, right? I missed it too. Okay, I was so angry. Okay, it was like a event of the century. Okay, I just missed it. Okay, just my luck. Anyway, so 3 words that you need to know are meteorite, meteoroid, meteor, and meteorite. Okay, asteroid. Nothing really much to say here. They are just between Mars and Jupiter. Okay, like I said, we have 4 rocky planets, right? 4 rocky planets, and then we have the asteroid belt, and then we have the 4 gas planet. So between the 4 gas planet and 4 rocky planet, there's an asteroid belt in between. Sort of acts like a protection, lah. Okay. collect meteor and become millionaire. But Jacinda, that's the problem. To go to space, you first need to spend a few $1 million. So that's not a very good investment. Okay, I mean, guys, if you have a few $1 million to spare, if you have a few $1 million to spare, you can go and register, you can go and sign up for the SpaceX program. The Elon Musk program, that means if he's going to Mars next time, you are the first batch to go. Wow, imagine the flex. Okay, your friend might flex his car. Hey, look at me, I have an Audi. Your friend might flex his house. Wow, look at how big my house is. You are flexing about going to Mars. Look at me, I'm the first guy who goes to Mars. That's the real flex right there. But if anything goes wrong, you will die first too lah. So I don't know. If you have a few million to spare, hey, why not? Money is not a concern to you. Okay, so Comet, they will just come here time to time lah. It's just like an ice on fire. Ice on fire. Ice with a tail, whatever. Okay, so nothing very much to say here. So this one, read this yourself lah. What happens if Earth is hit by meteor, asteroid, or comet? I'm sure there are tons of movies about this thing already. Okay, I can think of one is the Armageddon. That movie is a really stupid movie. Okay, they went up there and go and put bombs on the asteroid, try to destroy it. I don't know, I just find that movie pretty dumb. Everything will crash. Yeah, we all will die. Okay, life is fragile, just in case you haven't realized. Anyway, Form 3, Chapter 9, Space Weather. Okay, this is your sun. This is our sun. Our sun has 6 layers. Okay, you have the first 3 layer is the inner layer. The next 3 layer is your outer layer. Okay, first you have your core. You just learned this year, should be pretty fresh to you. Core is in the middle. It's the hottest, like 50 million degrees Celsius. And then you have radiation zone, your zone sinaran, which is the middle guy. And then you have the outer zone, which is the convection zone, zone perolakan. Okay, they will cycle the heat to the surface of the sun. So the surface of the sun has 3 more layers. You have your photosphere. This is where we see light. You look at the sun, please don't do that. But if you do, if you look at the sun, first of all, you'll be blind. But the light you see, it's from the photosphere. Chromosphere, you won't see this unless there's a solar eclipse. When the moon blocks the sun, you can see the white color ring around. That's the chromosphere. Okay, again, please don't look with your naked eyes. You will go blind. Okay, and the last one, funny enough, the layer is called corona. Yay! Okay, hey, you know, last time I used to explain this word. Oh, corona means crown. Then my students will be like, okay, why should I care? Now everyone cares. Wow, when I say corona, oh, sir, corona. Okay, so I guess it's a good thing. Now everyone knows what's corona. Okay, anyway, so why is it called coronavirus? Because the virus looks like a crown. It looks like a crown. Okay, it really does. So anyway, let's look at the phenomena on the sun. So if you look at the sun, the surface, you have like dots on it. Okay, we call it granules. Okay, and time to time, you will see some pimples on the sun. The pimple is called sunspot. Okay, it is the dark spot there. It's like you lah. Sometimes you have blemishes on your face. Okay, you have a spot here. That's like the sunspot lah. So every 11, 12 years, they will disappear and new sunspot will appear. It's just like you. Your old pimple will disappear and then next week, you have new pimple coming maybe somewhere else. That's how it works. It's the same concept. We call it the solar cycle. Okay, every 11 years, they will go through one cycle. So they will form new sunspot and the old sunspot will go away. Okay, so the important ones would be this prominence, solar flare, and CME. Prominence is a fire ring. Okay, it's a ring of fire. Can we stop that for pimples? Trust me lah. When you stop growing pimple, it's a sign of you growing old. I missed it. I used to have, okay, I don't really miss it. I used to have pimples all over my face. Okay, when I was in my when I hit my 25, when I was in 25, okay, I'm 30 this year. Okay, coming to 31. When I was like 25 already, my pimple just kind of stopped coming. I was like, oh, that means I'm getting old. Okay, so embrace your pimple. That means you're young. Okay, so prominence is a fire ring. It's a ring of fire. Okay, it's a ring of fire. It's not an explosion. Ew, why ew? Okay, so that's a ring of fire. Okay, so solar flare and CME is different. Solar flare and CME, they are explosion. Letupan is like whoop. Okay, this thing can happen for a very long time. It's a ring of fire. This thing can happen like few months, but explosion is like boom, few seconds, there's no more. That's so you imagine this is the boom boom lah. So you have your small boom boom, which is the solar flare, and of course you have the big boom boom, which is the CME. Okay, if CME were to happen, this only happens once every few thousand years, a big one lah. Okay, if this happens today, many people would die. Okay, this thing is pretty nasty. CME is pretty nasty. They produce a lot of radiation. You will get all kinds of skin cancer. It will disrupt our electricity, our telecommunication, and our GPS, everything. This thing is a huge disaster. But hey, it produces a very pretty aurora. So that's that. Okay, I'll talk about the aurora later. Okay, so of course you have your solar wind. This will happen 24/7 all the time. Okay, all the radiation from the sun is called solar wind. Okay, so you don't need to worry because we have a sphere protecting us already. We call it our magnetosphere, which is our magnetic field that shields us from this solar wind. Because if it doesn't, you will get all kinds of nasty radiation. You will get skin cancer in a few years. But do you? No, you don't. Even you stand out to the sun for a few years, you are like, hey, I'm fine, I don't get cancer because the magnetosphere has already protected you. Okay, so lucky us. Okay, so let's look at space weather and its effect. When you have very strong solar flare or CME, okay, when they reach the North Pole and the South Pole, they will disperse, okay, diserakkan, and you will see aurora. Okay, aurora. I think I told you this thing before, right? You can see this nearby North Pole or South Pole. Okay, many North Pole legend, North Pole stories, folklore, they actually revolve around aurora. Okay, why does it turn out green? Because green is the color that is most scattered. Okay, sometimes you will see purple if you are really lucky, but you won't see this pretty one. You usually see one very lame one. Okay, it depends on your luck though. If you can see a sky full of aurora, that means you're lucky. Okay, if you believe in Norse mythology, you know what it means? Norse mythology, people who believe in Odin. You know, last time when the Christians, they haven't come around, okay, the Europeans, they used to believe in Odin, Thor, Loki, Freya. They believe that aurora is created by a goddess called Valkyrie. Valkyrie is the goddess of battle. They believe that if the goddess of battle ride across the sky, she will create this very beautiful light. They call it aurora lah. Okay, but turns out it is not. It is just solar flare. Okay, so this is a very beautiful thing, but not towards our navigation system and telecommunication system though. Okay, if a solar flare is strong enough, it will disrupt your GPS, you will disrupt your telecommunication system. That means you're gonna make calls. It will also disrupt your power. Okay, so but hey, it looks pretty. Okay, it screws up your power and GPS and all your communication. They all go haywire. But hey, at least you fail in style. Yay, you get beautiful lights. So that's that. Okay, so anyway, so that's your space weather data. So how to they will analyze something called space solar cycle. Like I said just now, solar cycle is every 11 years. You have your solar minimum and solar maximum. So solar minimum is when they start their cycle, and then solar maximum is in the middle, and then they will cycle back to solar minimum. It's just like your moon lah. You have your new moon, and then 15 days later you get full moon. Full moon, 15 days later you get new moon again. That's your lunar cycle, your moon cycle. This is the sun cycle. Okay, so solar maximum is when your solar flare and CME is at the most active. Okay, 1 year you can have like a few strong solar flare. So if happen to be this year is a solar maximum year, you go to Finland or Alaska, you will see a lot of aurora. Okay, but if this year happen to be a solar minimum, that means you don't really see aurora. You'll be very lame. Okay, because there's no solar flare or CME. So choose to go there during your solar maximum. You will see the most beautiful aurora there. Okay, that's like one of my bucket lists. Okay, but it's just too expensive to go. Anyway, so let's look at our space exploration. What is mentioned by a few astronomers. First of it is Ptolemy. His model is called the geocentric model. Okay, that means Earth is in the middle of the solar system, which turns out to be false. Okay, the real thing is heliocentric. Turns out this guy is correct. Copernicus is correct. Okay, sun is in the middle. Okay, helio means sun. Okay, helio means sun. Geo means earth. Okay, geography, what? You study the earth, what? Okay, helio means the sun. Helio means sun. Helio comes from the word Helios. Helios is the god of sun in in Rome Empire. Okay, during the Roman times, okay, Tamadun Rome, they used to pray to this god of sun. They call it Helios. Okay, which they call it Apollo in Greek mythology. Okay, any of you read about Greek mythology? You have Zeus, Hades, Poseidon. Another one is Apollo. Apollo is the god of sun. Okay, so but in Roman times they changed it to Helios. Okay, there's another name for it. Okay, so that's your heliocentric lah. And of course, Kepler, he's the guy who corrected his model. He said that orbits are not actually round, they're actually oval, okay, or elliptical. So in fact, today we are still using his law. We call it Kepler's law. We use this to design our satellite. Okay, our satellite goes around our Earth in an oval shape because of him. Okay, so all these read for yourself lah. They're not gonna ask you, oh, 1990 what, they do this, they do that. No, 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 this is not what you need to know. Okay, I think I told you this Miasat 1 and 2. This is the reason why we have Astro. Okay, you can watch Astro. Who the hell still watch Astro, am I right? Okay, but if you still do, your Astro is possible because of these two. Okay, they are launched in 1996. That's why Astro has been around for 25 years. Okay, last year they celebrated that 25 years anniversary, what? Because Astro started in 1996. Because of this Miasat 1 and 2. Okay, so space telescope. The most common one would be your Hubble Space Telescope. This is how they observe the space, see whether there's any asteroid coming. That's the Hubble telescope. Okay. This field you roughly need to know lah. Rocket. This is what you use to launch your satellite to space. Satellite is the thing that goes around us. What is a space probe? Space probe is the thing that you send it to a planet to study the planet. Okay. Do you know there's a robot on Mars right now? It's called Curiosity. Okay. It's a very cute, tiny little robot. Okay. Every day they just go around studying, collecting sand, sending signal back to Earth, telling us that, oh, Earth, the Mars is like this, like that, like this, like that. So this is why we know so much about Mars, because of Curiosity. It's a space probe. Okay, so what is remote sensing? This is how they detect weather and all. Okay, I'm sure lately there's been this flood, right? I hope we are not affected. So how do they know, oh, next few days, Klang is going to flood. Few days later, Johor is going to flood. How do they know? Remote sensing. They just study the wind pattern and where is it going to rain. They can roughly tell which part will have heavy rain, which part will have a higher chance of flooding. That's a remote sensing. Okay, pretty awesome technology here. Okay, so why stream model they didn't tell? Not to say they didn't tell, is they actually gave out the warning. Okay lah. Do you know why is the flood so serious? Especially in Pahang. Do you know why is the flood so serious? Because let me tell you, 40% of Pahang forest has already been cut down. Okay, they are hutan simpan, hutan simpan and taman negara. You might say, sir, I thought we learned in geography, hutan simpan and taman negara you cannot cut one. Do you think they give a shit? No, they just sell the forest to other foreign company. They just chop our forest. Without forest absorbing the water, where do you think the water is gonna go? Flood lah. Okay, that's why our government sucks, because they couldn't care less about all these environmental stuff. When we flood, that's our problem. Okay, the politicians, they are too rich to care about problems like this. They live on a hill. Do you think flood affects them? No. Do you think they should care about you? No. They just pretend to care about you. Oh, you guys flood, so kesian, come, let me give you a bag of rice. Hey, then they go back to their $1 million mansion, have their expensive food and sleep on the expensive bed. They couldn't give two shit about you. Okay, that's the truth. Anyway, moving on, let's go to our exercise. Let's go to form this one, form 3 space chapter. Okay, let's look at question 2. I'm not going to discuss all the questions. All they want is money. Yeah, our money. Okay. Just in case you haven't realized lah. Okay, so I'm not going to discuss all the questions because there's a lot of questions. There's what 38 pages here. I'm just going to discuss some of it. Okay, they're getting rich because of us. Yeah, keep your people stupid enough to pay you, then you'll be rich as well. Okay, no future in Malaysia. I hate to say it, but I agree with you. Okay, so match the following object with their characteristics. So galaxy is the cluster of stars, planet, dust and gas. Nebula is dust and gas cloud. Okay, that's Thanos' second daughter, by the way. So Milky Way is galaxy where our sun and star is located. Okay, black hole is the final stage of star that's very strong gravitational pull. Okay, black hole is so dense and the gravity is so strong, even light cannot escape. That's why they look black. Okay, but hey, that's astrophysics already. I'm not going to go too deep into that because you have all kinds of blur. Okay, very hard to explain. Okay, so match the different types of galaxy. Okay, this is the roundy one. Okay, the roundy one is the ellipse. Okay, the spinny one is the spiral, and the chincai one is the irregular. There's no circular galaxy, Okay, no such thing, So next C, mark the correct statement and the incorrect statement. Our sun is located in the center of the Milky Way. No, we are not. We are at the side of the Milky Way. Okay, in fact, we go around the Milky Way. Our solar system goes around the Milky Way. But it takes a lot of time, All right, so next, spiral galaxy contains hot young star. Yes, true. Okay, galaxy are classified based on their distance. No, they're classified based on their shape, not distance. Okay, number 4, the Milky Way is a barred spiral galaxy. Yes, it is. Okay, what is bar? That means you look at the side. Our Milky Way actually looks like this. Okay, it looks like a bar, isn't it? Okay, it looks like a bar. But you look at the top, okay, our galaxy actually looks like this. Okay, so spiral. So we are a spiral barred galaxy. Okay, moving on. Let's go to D. Fill in the correct answer. So what is a luminous ball of gas? Luminous means glowing lah. Okay, mostly hydrogen and helium held together by gravity. That would be your star. Okay, nearest star to Earth is the sun. Okay, like I told you before, more than half of American, they don't know that our sun is a star. Okay, it's a pretty dumb country. That's why they all refuse vaccine, because they are too dumb. They thought, here's the problem, they are dumb, but they thought that they're very smart. They thought, oh, vaccine is killing, vaccine is a lie. So that's why US has one of the highest COVID death rate in the world. Okay, so the up one is correct. Which one? Yeah. Number 4 one, right? Okay, so next, what is a group of star, dust, and gas? That would be your galaxy. Okay, so the last one, what is a spiral galaxy? That would be our Milky Way. Okay, by the way, in BM it's called Bima Sakti. I have no idea what kind of translation is this. Don't ask me. Okay, it's just the way it is. Anyway, moving on. Let's go to question 2. Let's skip this, shall we? Because it's the same question. This is irregular. This is elliptical, and this is spiral. So pretty much the same thing. Let's skip, shall we? Let's go to number 3. This is how our sun is born and died. So A is what? A is your nebula. Obviously. B, so you see red giant, obviously B is a red giant too. Okay, Raksasa Merah in BM. Okay, and of course C, when our sun die, someday in the future, they will turn into a white dwarf. Okay, Girdil Putih, a star without any purpose. So we will all die. But that's a few billion years later. You are long dead, so don't you worry. So next D, what is this? This is your super red giant. Okay, your super red giant, or just call it a super giant lah. Okay, super raksasa. And then E is gonna be your supernova. I'm not gonna write this. It's the same question, same answer. F is gonna be, this one is your neutron star. Okay, bintang neutron. And G is gonna be a black hole. Okay, this neutron star is pretty damn heavy. Okay, a few gram will cost a few thousand kilos. Okay, kilos as in heavier 4-5 times of your car. Heavier than your car. In just a few small bits like that. That's how heavy they are. Okay, that's why they say Thor's hammer is made from neutron star. It makes no sense. Okay, so next flowchart shows predict the life cycle of a sun as a star. So R, where is this R here? So state the type of star of the sun according to its size and color. Okay, so what's the size of our sun? Size is normal. Wait, let me write the English first. Size is gonna be medium. Okay, sederhana. And color, we are yellow. Okay, kuning. So our sun is a yellow medium star. Okay, middle, not too big or not too small, just okay. So C, what is the state of R? Briefly, what happens at the state of R? Okay, R is the birth of our sun. You see, they start from nebula, they turn into a sun. That's how they are born. So that's the birth of star. Okay, kelahiran bintang. So what happens? Okay, first of all, you have to talk about the nebula. Okay, nebula, they are attracted by strong gravitational force. Okay, so nebula contracts due to gravitational force. Okay, nebula mengejut disebabkan oleh daya gravity. Okay, so they contract. So when they contract, what happens? They become really hot and then they start burning. Okay, not burning lah. It's called nuclear fusion, by the way. It's nuclear. Our sun is a nuclear energy. Okay, it's a nuclear reactor. It's a very big nuclear reactor. Okay, so nuclear fusion occurs. Okay, this is called percantuman nucleus, I think. Okay, you will learn this in Form 4, don't worry. You have two types of nuclear reaction. You have nuclear fission, pelakuran nucleus, that's the splitting of nucleus, and you have nuclear fusion. Both can be used to make bomb. Okay, the Nagasaki and Hiroshima bomb, you heard of the atomic bomb, right? Those atomic bomb, the two that thrown in Japan, Nagasaki and Hiroshima during World War II, those are fission bomb. Okay, and the Russians, okay, or should I call it the Soviet, they actually made a fusion bomb. We call it hydrogen bomb. Okay, fortunately, we have no chance of using it lah, but who knows, in the future we will. Okay, fusion is even stronger. If you make a bomb with nuclear fusion, basically you are using the energy like the sun to kill someone. Awesome, isn't it? We human beings just somehow find new ways to kill each other. Yay. Okay, so D. State the type of stars P and Q that form according to the size and color. So what is P and Q? This is when they start to die lah. Okay, so when they start to die, P is going to be a red giant. Okay, raksasa merah. And your Q is going to be a white dwarf. Okay, keridil putih. Okay, our sun just died without an explosion. It's just going to be chill. Our sun very chill and there's no drama. So E, give one example of star P and Q. You don't need to know. Okay, you don't need to know. So there's a white dwarf that I know is called Sirius. Okay, Sirius. Any of you watch Harry Potter? Sirius Black. The Sirius, the name comes from the white dwarf lah. It's the name of a star. Okay, Sirius. If you watch Harry Potter. So F, predict the impact will be on our Earth when Sun has transformed into P, perhaps in a couple of billion years. Okay, so what happens when our Sun becomes a red giant? Okay, first of all, red giant is hot, really hot, because they are towards the last ending already. They burn even hotter. Okay, so it is red giant is hotter. Okay, lebih panas. So what we'll do, our this one is very open-ended answer. You can say the Earth heats up. Okay, water evaporates. Okay, bumi memanas or air menyejat. Basically we all die lah. Okay, is black hole hot? No. Here's the thing lah. If you ask any scientist, how is a black hole like? Is it hot? Is it black? Is it this? Is it that? Nobody can answer you because they are so heavy. They are so black. Nobody knows what's inside. The gravity is just simply too strong. Okay. This one, next time you go study astrophysics, then maybe you will learn something like. Okay, but I've not heard any Malaysian who study astrophysics though. Very rare lah. I mean, you cannot get a career here. Okay, you go US lah, you can work in NASA or something, but Malaysian, not so much. Okay, our space exploration is very lame. I hate to say it. Okay, so next, number 4, this one, do it yourself lah. It's a repetitive question, so let's skip ahead. Oh, we don't have much time. Let's go to the next chapter, shall we? Let's go to, I'm sorry for rushing because I have to. Let's go to this one. I don't think I need to tell you the answer. If you still cannot arrange your planets, shame on you. Please go to primary school. Okay, anyway, let's go to our number 2. Okay, so astronomical unit, AU and light year. Which page we are at? We are at page 10. Okay, page 10. So AU and light year are used to measure relative distance planet from the sun. Okay, describe the meaning of astronomical unit and light year. So what is AU? AU is the distance from Earth to Sun. Okay, jarak antara bumi dan matahari. Okay, so light year is the distance traveled by light in a year. Okay, distance traveled by light in a year. Okay, jarak digerakkan oleh cahaya dalam setahun. Okay, in 1 year, how far they travel. So that's a light year. That's a really long distance. Okay, so anyway, they say in solar system, Mars is the 4th planet from the sun. So the distance is 2.28 times 10 to the power of 8. You see, do you like this number? I don't, because it's a really big number. Nobody knows how much is this. Okay, so you see, they already give you the formula. Calculate the distance of Mars from the sun in AU and light year. They already give you the formula. You just sub your 2.28 times 10 to the power of 8 into here and into here. You should find your distance in AU and distance in LY. Okay, so the first one, 2.28 times 10 to the power of 8 divided by 1.5 times 10 to the power of 8. Second one is same thing. Divide by 9.5 times 10 to the power of 12. I'm going to give you the answer straight. The first answer is 1.52 AU. Second answer is 2.4 times 10 to the power of -5 LY. Okay, we don't really use light year because it's such a big number. Light year is really too far. So if we measure galaxy, then maybe we use light year. But in this case, AU is more suitable. Okay, what does it mean by 1.52 AU? Like I told you, from our sun to our Earth is 1 AU, 1 banana. Okay, you don't think of AU, think of banana. From our Earth to the sun is 1 banana. From Mars to sun is 1.5 banana. You see, now it makes so much sense, right? That means from Earth to sun, 1 banana. From from Sun to Mars is 1.52 banana. That means from our Earth to Mars is going to be 0.52 lah. It's going to be half banana length. You see, makes sense, right? This is why we use AU, because it's such an easy number to understand. This is used to measure planet. But next time, if you're measuring galaxy, something even bigger, then you need to use light year already. Okay. Anyhow, so number 2, why is meter or centimeters not suitable to be used in measuring distance? Well, it's going to be a very big number. Okay, so the number would be too large. Okay, nombor terlalu besar. Okay, it could be like 16 zeros. Okay, the number will be too big for you to understand. Too big for you to figure. Okay, so next, tick for the correct statement and cross for the wrong statement. Distance that light travels in 1 year is a light year. Yes, correct. AU is the average distance between Earth and Sun. Yes, true. So a light year is a unit of time, not distance. No, light year is distance. Okay, number 4, distance of stars are expressed in light years. Yes, it is, because they're too big. Light travels around 9 million kilometers in a year. Okay, how much is a million? Million is 9 times 10 power of 6 km. Is it 9 times 10 power of 6? No, it is not. It is 9 times 10 power of 12. That's like double a million. So no, this is wrong. Okay, so next, moving on. Let's skip to the next chapter again. Let's go to page, let's look at the asteroid one. Let's look at page 18. Okay, let's look at page 18. So the first one, what is a comet? How do you know it's a comet? You see ice. Like I said, comet is a ball of ice. Okay, so next, meteoroid is basically a small stone. So you see small fragments of rocks. Okay, small rocks. So if you see a belt, this is definitely an asteroid. Okay, so next, B, meteoroids that enter the Earth atmosphere and reach the surface, sampai ke permukaan. That rock is called a meteorite. Okay, meteoroid, meteorite. So it's like a sequence. Outside, it's called meteoroid. Coming into Earth is called meteor. Reach the surface is meteorite. So next, the comet's tail is always what the sun due to the solar wind blowing from the sun. So it's always away from the sun. Okay, that means this is the sun. When the comet comes, the tail is always away. Okay, because the solar wind that blows. Okay, the angin surya. Okay, next. Again, let's skip to the next chapter. I know I'm rushing like mad here, because we are supposed to do this in 2 weeks. Now we are doing in 1. So next, let's look at the number 1, page 23. I'm kind of doing like a roller coaster here. So please hang on for your dear life. Okay, so structure of the sun. S is the core, torus. And R, the middle one is your radiation zone. And then the outer one should be your convection zone. Okay, in BM it's called zone perolakan. I'm sure in Form 2, when you learn about the transfer of heat, you learn what is sinaran, right? Radiation. And you learn what is convection, perolakan. Okay, 3 methods of heat transfer: what? Conduction, conduksi, convection, perolakan, radiation, sinaran. Okay, so basically they named 2 after this. So B, underline the correct answer. The outermost layer of the sun atmosphere. Atmosphere means the outer layer. Hey, that's your corona. Okay, so next. what is the surface of the sun, which is made of granule. Okay, granule is when you see the bintik there, that's gonna be your photosphere, the thing that you can see. Okay, like I said, chromosphere you cannot see unless there's a solar eclipse. End of story. You will not see chromosphere. Okay, next, match the following space weather. So sunspot. Okay, sunspot is gonna be the dark region. When you see dark, gelap, you know that's your sunspot. Okay, so next, prominence. Prominence is gonna be a huge loop of glowing gas. Like I said, loop. There's a circle of gas. Okay, it burns for a few months. This is a very long process. Whereas your solar flare is like a boom, then nothing. It's a very short time. So your solar flare is gonna be here. Strong, spectacular eruption of gas. Of course, your solar wind is gonna be ejection of planet gas particle. Okay, solar wind is full of radiation. If you get solar wind full on, you will get cancer. Okay, this thing is really, really dangerous. Okay, so the interplanetary magnetic field, that will be a magnetosphere. Okay, the Earth's protection layer. Next, number 3, mark for the occurrence due to effect of the space weather and which are not. So, space weather is like your solar flare, your nyalaan surya. So, what will solar flare cause? Does it disrupt your telecommunication? Yes, it does. Okay, they will kacau your phone signal. Does it disrupt your high tide, low tide? No. High tide, low tide is because of the moon. Okay, because moon got gravity. At night when we are facing it, the thing will go up, high tide, air pasang. And when you are not facing, there's no moon pulling on us. In the morning, the tide will go down, low tide, air surut. Okay, so next, disrupt your GPS. Yes. Drought. Yes. Okay, because they're hot. Okay, so let's do one more before we go. So what is a granule? Granule is the bintik, the dots on the sun surface. That's gonna be your heat convection. I think this one. Arus perolakan. It happens at the photosphere. See, photosphere is the surface. So prominence is gonna be your increasing and decreasing sunspot. Okay, here's the thing. Prominence, the fire loop will happen near sunspot. Okay, when you have black sunspot like this, at the nearby you will see a prominence. Okay, because the prominence is very hot, they suck energy from surrounding. So when the surrounding becomes cold, you will see sunspot. So usually when you see sunspot, when you see a bunch of sunspot nearby, you will surely find a prominence. The Semarak Surya. Okay, that's just how it is. All right, you know what? I think I'm gonna stop here. Sorry, I cannot discuss all because this is very long. But as I said, this part is not important in your exam, so please don't focus. Don't worry, I'll put the answer in Google Classroom. You can go and check it. During weekends. Okay, so we shall continue with another thing next week. So thanks for coming. Must reduce questions. Yes, I agree. Okay, so next week, if you're coming for physical, then I'll see you physically. Okay, if not, then we'll see each other online. Okay, so thanks for coming. Good night, everyone. I will see you next week. So take care. Bye-bye.